So friends, in today's class, we are going to learn principal component analysis. Now, it is one of the most powerful technique, or it's a kind of a statistical technique to convert a high dimensional data to a low dimensional data. So what do I mean by high dimensional data to low dimensional data? Let's say if I got a data set in which I got, you can say some predictors and the you can say the target variable. So basically, what are my predictors or my you can say the dependent independent variables. So in principal component analysis, some of the independent variables are not explaining the data. So basically, it's a you can say it reduces the dimension of the data and it only focuses on those features as an independent data that explains the you can say the target variable or the response variable. You can say much more as compared to whole of the data. So like what do I mean by whole of the data means these features are selected on the basis of variance, and the thing with the highest variance is called the first principal component, and the second highest variance is the second principal component. So there are some advantages of using the principal component analysis, that the training time of the algorithm reduces with less features. So if we have less features, so the training time would be reduced. So in reality, it's not possible to like analyze the data with so many features. So it's very important to, let's say, reduce the data and focuses on only on those features which is most significant for the data. So it's a basically it focuses on those features only which is explaining the predictors a lot, right? So another which important thing for like principal component analysis, it is very natural to use like the data that should what we are using should be normalized. So it is one of the most important thing. So in today's lecture, we are going to study about principal component analysis using the scikit-learn. So I'll be using the library which is the scikit. So first of all, but let us start with the very familiar libraries that we have worked in the previous session as well. So we will be importing NumPy. So first of all, let me import the libraries. So let us import the NumPy. And import pandas as PD, right? So these are the two libraries I'll be importing. So let me create some more cells so that we will be using. Now let us import the dataset. So like I'll be using a very famous dataset which is called as IRIS dataset. We have worked in our logistic regression class. So I'll be using PD from the pandas library dot read underscore CSV. Let's say I want to use IRIS dataset. I've already called in this directory dot CSV. Let me show you the dataset.head in order to make you familiar with the data that we will be dealing with. So this is one of the data. So first five row as a summary, first five row as a summary, along with all the features it is highlighting. So you can see Setosa, these are the species, right? Let me call it again. Yeah. So these are the species which is present on the IRIS dataset, right? And these have also showing you some features of the species like sepal length, sepal width, petal length, and petal width. So length, it must be the length of the sepal. Width, it must be the width of the sepal. Petal length and the petal width similarly, right? So guys, let me also do some data pre-processing, that which is very important, so that we can divide the data into features and corresponding labels. Let us follow with an X label and Y label. So data set, from the data set only, let's say data set drop. So drop is generally dropping the particular like the class which I don't want, right? So let's say if I don't want species, and okay, so let me take small because I'll be utilizing it, and let me take let's say Y as, let's say, data set, and let's say it is comprising of only species. Okay, so let us work this out. Let me show you X. So it does not contain the species, guys, as you can see. And let me show you the Y. So it only comprises of the classification. So this is Y is my, you can say, uh, target variable or the response variable. Now let us split the data into the training set and the test set. So since I already mentioned that I'll be using the scikit-learn, so I'll be importing train underscore test underscore split, say x underscore train, and let's say guys x underscore test and y. Okay, one thing important, since I've taken it to be small, so I'll be taking it to be small, and y underscore train comma y underscore test is equal to train underscore test underscore split comma y comma, let's say the test size is 80/20. So the testing data would be 20% and the training data would be 80%. So generally we use testing data for in order to check the model performance, and whatever the computation are we doing, we are focusing on the training data. Let's say 0. Let me run this block of code. Okay. So now the data is splitted. So as I mentioned earlier, that principal component analysis performs best with normalized features. So we will be performing some scalar normalization to normalize our feature. So let us execute a block of code. So I'll be calling from sklearn pre-processing. So I'll be importing standard scalar. So this is one library in order to normalize the data. So like let's say SC is my standard scalar. X underscore train, that is SC dot fit underscore transform. Now this is what I'm doing. I'm just storing a normalized value under in this particular variable, which is x train. Now, if you compare this x train with this x train, it contains the features which is unnormalized. So after this, after following this block of code, x underscore train will be a normalized data. Similarly, for the, you can say the testing. Okay, so now it is populating some error, guys. Let me have a look. Okay. The spelling was wrong. So guys, it's an advice. So always just take care of the spelling. Happens during the time of coding. Okay, now it is saying that there is an error. Okay. Scalar. Okay, it's not scalar. Okay, I think this would work. Yeah, perfect. So it worked. Now let's say if let us apply principal component analysis. So like it will just generally will follow some basic block of code. So in order to initialize the PCA using SkyCAD, so from the, you can say SkyCAD decomposition, I'll be calling the principal component analysis. So there is only two steps. At the first step, you just need to initialize the principal component analysis class by passing the number of component. And in the second thing, you have to call fit and then transform method. And this method returns the specified number of components. So I'll just show you with a block of code. So like from, you can say sklearn dot decomposition. Let me import principal component analysis. Now let's say if I give this variable with the this method a name as PCA, I'll be using it in my next computation. I'll be using it on the training data. So I'll be just transforming it. And let's say x underscore test. So I'll be using PCA dot transform. Okay, so let me call this. Okay, fine. So in the above code, we created a PC object named small PCA, and we did not specify the number of components. Hence, all the four features. So what I am talking about, all the four features. So these are the four features. 1, 2, 3, 4. So all the four features will be returning both the trainings data and the test data. And it also contains a species, or you can say the class, which is explained variance ratio, that returns the variance caused by each principal component. So let me execute this block of code. So explain variance means, so which is explaining my data, or you can say the predictor. Okay, so right now we have explained. So now, okay, so guys, if I call this explain variance, so it gives me some arrays like 0.722, 0.2397, 0.033, 0.0046. So it can be seen that in the first principal component is responsible for 72.22%. So it is 72%. The first component is explaining the variable. Now, if I talk about the second principal component, it is actually explaining a variance of 23.9%. And similarly, if you add these two parts, so it comes out to be something around 96.21%. I can say my first two features, which are like sepal length and the sepal width, is explaining the 96.21% of the data. So while doing some computation, let's say if I got a very big data comprises of 100 features, now you can use principal component analysis in order to focus on only on those features which is explaining the maximum variance of the target variable. So this is the fundamental usage of principal component analysis. So like now let us visualize some more, you can say some more coding on the testing data as well. So I've already like imported PCA, right? So like now guys, let us focus on like some, we have also focused on the training data and the test data. So now let us do some random forest classification using and in order to make the predictions. So what I'll be using from sklearn.ensemble. I'll be importing random forest classifier. So my classifier is random forest classifier. Let's say maximum depth is 2 and the random state, let's say 0, and classifier dot fit x train x train and the y train, and y underscore pred classifier and dot predict. Okay, so we are using the random forest classifier in order to make the prediction. Okay, I think there is okay. So let me show you some performance evaluation, and we'll be also be using the confusion matrix. So from sklearn.matrix, we will be importing confusion. So confusion matrix is basically it's a 2 by 2 matrix which is based on the frequency distribution of the features. We'll be importing accuracy score as well. Let me take CM as a confusion matrix. So by pred, we will be using the random forest classifier. So now let us import the confusion matrix. So this is my confusion matrix. So it is giving you the data based on the three features. So this is